Assalamu alaikum. My name is Fatima Junaid, and for my group's operating system project, we decided to describe the hospital triage system through explaining the round robin and multi level scheduling. In our group, we have members Farah, Iman, and myself. This project explains round robin and multi level queue scheduling using a hospital triage analogy. We created an animated video of 1 to 2 minutes, and codes were created to visualize how processes are scheduled in the operating systems. Round robin gives equal CPU time to all tasks, like a clinic treating patients in turn. Multi level queues separate tasks by priority, like a hospital prioritizing emergency cases. The goal is to simplify OS concepts using relatable real world examples. In multitasking systems, CPU scheduling ensures fair and efficient process management. Round robin, each process gets equal CPU time in a rotating order. In the multi-level queue feedback, processes are sorted into priority levels from highest to lowest. Inspired by the hospital triage, where patients are treated based on urgency, our animation and codes show how these algorithms work together in the real world systems.
Okay, now for the problem statement. So the situation is emergency departments always face an overwhelming numbers of patients, especially during a crisis or peak times. Different patients have different levels of urgency. The problem is the current triage system only based on human judgment or basic first come first serve methods. These are inefficient and unreliable, which cause delays in treatment for the patients. So for our proposed system is round robin scheduling is to ensure fair time for every patient, and multi-level scheduling depends on the urgency of patient cases. So the benefits of it is it reduces wait times and delays, fair for all the patients, and improve efficiency.
For our project, we also looked into some related works. Some of the works that we have looked into were books that were given to us during the operating systems courses. So let's see what some of these reference books tells us. One of the books suggests that round robin is fair, but time quantum must be tuned. Another book suggests that multi-level queues need aging to prevent starvation. A third book says that modern operating systems often combine both of these strategies of round robin and multi level queue systems. The fourth book suggests that scheduling must reflect real world process categories, and the last book suggests that clear conceptual models help with student understanding. Now that we have looked into the related works, I would like to present our animation. In this video, we'll understand how operating systems manage tasks using two key CPU scheduling methods, round robin and multi-level queue scheduling, by comparing them to how patients are treated in a hospital. Round robin is like a clinic waiting room where everyone takes turn. Each patient, or in our case, each process, gets the doctor's attention for a short fixed time, like a time slot. If they're not done, they go back to the end of the line and wait for their next turn. Imagine three patients. Alice needs 10 minutes, Ben needs 4 minutes, and Clara needs 6 minutes. Each gets 4 minutes with the doctor before rotating. The doctor sees Alice, then Ben, then Clara, then back to Alice, and so on. This keeps things fair, just like in a time sharing system where every process gets equal attention. Now picture an emergency room. Patients are separated into different priority levels. Critical patients go to the emergency lane, moderate cases wait in the regular line, minor issues are in the general waiting areas. This is what multi-level queue scheduling looks like. The system sorts processes into multiple queues based on urgency or type. In a hospital, the doctor always checks the emergency queue first, even if others have been waiting longer. Similarly, in CPU scheduling, the processor serves the high priority queue more frequently, while lower priority processes wait longer. This ensures critical processes are addressed quickly, just like saving lives come before minor checkups. Round robin is like a clinic. Everyone waits fairly and takes turns. Multi-level scheduling is like a hospital. Patients are prioritized by how urgent their condition is. Some systems even use both, rotating fairly within each priority level. Together, these methods help keep systems efficient, responsive, and smart about what matters most.
So for the methodology, there is 4 phases. So for phase 1 is requirement analysis. As you can see for the flowchart is our project management flowchart. Okay, then phase 2 is hardware and software requirements. So there is hardware requirements and the software requirements that we need to do our proposed system. So for phase 3, this is the task distribution between 3 of us, the project report, project presentation, animation and coding implementation. Okay, now for phase 4, the research and literature review. This is some of the most frequently used terms in literature to ensure the understanding of user round robin and multi-level queue scheduling in our project. So, firstly is process. It is represented as patients in our system, burst time, treatment time required for each patient, waiting time, amount of time a patient has to wait before being treated, turnaround time, total time from the arrival of patients until the completion of treatment for the patients. Okay, now for the mapping to our operating system is the CPU. It is represented as a doctor who treats one patient at one time. Q, red, Q1 for critical patients, yellow, Q2 for urgent patients, green, Q3 for non-urgent patients, and time quantum is duration of treatment given per round to each patient in queue. Okay, now for the design and implementation. So this is the system flow chart. So firstly, it initialized hospital triage scheduling system, then it input patient data, and you can see Q1 for critical patient, Q2 for urgent patient, and Q3 for non-urgent patient. So we set the time quantum in our coding for 4 minutes, Q2 for 6 minutes, and Q3 for 10 minutes. After we set it, we are going to go through process Q1 as is the most urgent cases, then Q2 and then Q3. And then we're going to apply round robin scheduling, and then we calculate completion time, waiting time, and turnaround time, and then we display the average waiting time and display turnaround time for Q1, Q2, and Q3. So this is the coding implementation. So for the first part is initialize hospital triage scheduling system. We use Java for the coding. So over here we create 3 MTQs for different priority levels for each patient, which is Q1 for higher priority, Q2 for medium priority, and Q3 for low priority. Okay, now we set the time quantum, as I've said before in the flowchart, is the Q1 is 4 minutes, Q2 6 minutes, and Q3 10 minutes. This is the time limit for each patient that will be attended by the doctor before switching to the next patient in the same queue. Okay, now this is the input patient data for each queue. Q1, input Q2, and input Q3. This input how many patients in each queue and input the burst time of each patient. It required the treatment time. So and then we begin processing queues based on priority. This process queues of patients using time quantum starts with Q1 as the highest priority, followed by Q2 and then Q3. Okay, now we apply round robin scheduling per queue. This is the coding, and then the coding means each patient has a turn with the doctor. If the treatment are not completed, they will go back to the end of the line, and this will be repeated until all the patient's treatments are done. And then we calculate waiting time and turnaround time. This calculate the turnaround time, which is the total time from when the patient enters the system until the completion of their treatment, and calculate the waiting time, which is the total time that the patient spends waiting before receiving treatment, which is turnaround time minus actual treatment time. And lastly, we display the results. This show the results of burst time, completion time, waiting time, and turnaround time.
So now I will be presenting our result and discussion. Here you can see the Java programming for the multi-level queue and round robin. Here you can see the time quantum. This is a static. For the first time quantum is 4, second one is 6, and the third one is 10. Here you can see for queue number 1, which is the highest priority, and the medium priority for Q2, and Q3 is the lowest priority. Here as well you can see the calculation for turnaround and waiting time. So now we'll see the results. You can see for the highest priority will put 3 processes, and the burst time will be 30, 25, and 20. And for the medium priority queue, we'll also put 3 processes with 20, 15, and 10. And the lowest priority queue is 10, 8, and 5. And now here you can see the result for the timeline. For the first queue, the highest priority queue will be finished first. You can see here the time quantum is 4, so each will get 4 time slot, and will be repeated until every processes have 0 burst time remaining. And it's the same for medium priority. So you can see the time quantum is 6, so each processes will get 6 time slot and will be repeated until all the remaining burst time is 0. And then the last queue, the lowest priority queue, will get 10, and you can see each processes will get 10 time slot. And since all processes have 10 and below burst time, it will only be completed by 1 cycle. So from the process stats, we can see that since the highest priority queue have the lowest time quantum, this is because so each processes in the queue can be processed fast with low and minimal wait time, while medium priority will have average wait time and turnaround time, while the lowest priority will have the longest wait time, which align with the hospital triage system, where the highest priority, which is the critical patients, will need to be seen the fastest with minimal wait time, while the lowest priority, which is the green zone patients, will have more wait time as they have lower urgent need. During our project development, we faced several challenges, including topic selection, task division, and finding suitable references. Initially, we had to switch our chosen topic due to the first-come, first-served system, but then we quickly agreed on a new one, which is the round-robin and multi-level queue scheduling, which we then apply our system, which is the hospital triage system. And after that, we had to delay the task division due to our commitment issue, as each members were occupied with other coursework, but we managed without conflict. And then one of the bigger challenges was finding references, especially from past projects, which most discussed with different topics. However, through continuous research and teamwork, we successfully produced a cohesive and well-structured project report. This project greatly enhanced our technical and soft skills, which deepen our understanding of CPU scheduling, especially how to implement and balance different queue priorities and choose the appropriate time quantum values. We also learned the importance of edging and multi-level queues to prevent starvation of the lower priority process, a key concept that ensures fairness and system efficiency. And beyond technical knowledge, we also improve our time management, teamwork, and communication. The final implementation using the Java and the animations help us visualize the step-by-step scheduling process more clearly. Finally, we'd like to sincerely thank our operating system lecturer for her continuous support and guidance throughout this project. Her clear explanations, practical examples, and complete lecture slides made it easier for us to understand complex concepts like process scheduling. Her guidance helped us stay focused on the scope of the project and what was expected in our report. We truly appreciate her straightforward teaching style and her dedication to ensuring we understood each topic. This project would not have been as smooth and successful without her support.